let's keep going. So the latest video was about security groups within AWS, and this video is all about understanding SSH key authentication. I was trying to pass the quiz, but it was like a fail. Okay, let's keep going.
In order to work with EC2 instances, you're going to need to understand SSH key authentication. What's typically required when you want to log into a remote Linux server, like a new Amazon Linux EC2 instance? Port 22 must be accessible from your location. The host must have SSHD running, and you must have a username and a password. Password authentication must be enabled, and then the client logs in with some SSH client software, such as OS10's built-in SSH command or PuTTY for Windows. The default situation in AWS is a little different. First, Amazon Linux automatically provisions an admin-level user called EC2 user. Second, they do not provide password login by default. Instead, we will rely on SSH key authentication. SSH key authentication replaces password authentication using public-private key encryption. Logging in with your private key requires the remote host has the public key installed. First, you must generate a public-private key pair. This can be done on Linux or macOS with the SSH keygen command. Then you must copy the contents of the public file into the authorized key files of the remote user. Of course, this requires you to have access to the machine in the first place. Good news, these steps are the ones AWS does for you. AWS will generate a private and public key pair for you. It will remember the keys it creates and prompt you to use them anytime in the future you need to specify an SSH key. AWS keeps the public key to provision onto instances, but it does not keep the private key. Instead, you'll be given a one-time opportunity to download the private key. You can save it anywhere, but the default location on Mac and Linux systems is home/username/.ssh. The key files are just text files, but you must treat them specially before you can use them. SSH requires that your private key be set to read-write only by the file owner, with no access to groups or to the world. In Linux file permission terms, this means permission bits 0400. Treat this key like a password, and do not share it. Later, when you create an EC2 instance with this key associated, AWS will automatically provision the public key into the EC2 user's authorized keys file, allowing you to log in as EC2 user by using the corresponding private key. So how do you actually use this key? From a Linux or Mac system, it works like this. To use the private key for authentication, simply use the -I flag on the SSH command, followed by the path to the key. This works on most Linux and Mac systems. Don't lose this key or you'll lose access to your instance. AWS does not have any backdoor into your EC2 instances. They can't help you if you can't get in. One last thing. Over time, you may accumulate a number of SSH keys for different services. It can be hard to keep track of what's what. You can make future logins convenient by adding your private key to your SSH key ring. The key ring is a list of private keys that the SSH command attempts to use when you try to log into a remote host. On Linux or Mac systems, it is controlled by a command called SSH add. Despite its name, you'll use SSH add to add, remove, and list keys in the key ring, as shown here. Finally, a warning about the SSH key ring. Some operating systems block your login after 5 failed attempts in a session. If you have more than 5 keys on your key ring, you may quickly hit this limit before getting to the right key. If that happens, don't worry. Just use the D flag to remove all your keys, then add only the ones that you need. Removing keys from your key ring doesn't delete the key. It just means that it won't be automatically tried until you add it again.
Okay, as I told you before, I was trying this quiz, this quiz. It was a fail because I couldn't respond the first question, but it's okay. We can try again. I can try one more time. So we have our first question here. Availability zones are close enough, the latency is negligible. All the answers. Far enough apart, so the disaster is one is unlikely to affect the others. Availability zones are either for local balancing across. Okay, the last time as I clicked here in this answer, far enough apart so that a disaster is one, but it told me that I was wrong. So in this case, and he gave me a video to recap the the knowledge, or to recap the concept. And I have recapped the video, and I think it's this one. Availability zones are, and it says we are wrong again. That's cool. Okay, so it says understand AWS EC2. So we need to understand this concept in order to pass this first question. So they say to watch the 6 minutes the video here. We have to put the video here in 6 minutes.
When we talk about compute resources in AWS, it all comes down to Elastic Compute Cloud,
I'm not sure.
or EC2. EC2 instances are virtual machines.
I'm not sure, but I have watched this video before, and they talk about this question here. They talk about the availability zones just right here, I guess.
Seoul, Tokyo, Mumbai, and Sao Paulo. Almost everything you build in AWS is built within the context of a region. Only very few resources are cross-region. When selecting your region, you want to think about latency that your instances need to connect to. If your AWS, good rule of thumb, represent large geographical areas, and they are closest to you.
Okay,
regions represent large geographical areas, and they are logically isolated from each other. Within a region, AWS still gives you options to geographically separate your resources by dividing regions into availability zones. Availability zones, or AZs, are the physical data centers that make up an AWS region. They're named by letter, so the first AZ in the US East 1 region is called US East 1B. Geographical separation is important when you need to build applications that must not go down, even if a disaster strikes. Each AZ is located far enough apart that a physical threat to one AZ, such as a fire or flood, will not affect the others, but close enough together so that network latency between them is negligible. This makes multi-AZ load balancing highly effective for building fault tolerance into your application.
So the answer is there. So we can try one more time this question. Availability zones are. So a availability zone has close enough, the latency is negligible, and also it is far enough apart so that the disaster is one is unlikely to affect the others. Oh yeah, wait. Okay, this one, and ideal for load balancing across. Yeah. So the right answer is all of them. You're correct. Okay, let's keep going. What can you not do on an elastic load balancer? Okay, my friend. What can you not do on an elastic load balancer? let's see, to perform HTTP health checks, terminate SSL, direct traffic to an RDS instance, load balance across multiple H2 instances. Elastic load balance. So what can you not do? Terminate SSL. I'm not sure, but is for me is the first one. Perform HTTP health checks. Let's check this out. What can you do not on elastic load balancers? And it says we are wrong. That's bad. Okay, understand. So we need to understand the AWS elastic load balancers.
Let's take a look at how AWS can distribute traffic across multiple instances using elastic load balancers. Imagine you have a web application on one instance. The security group exposes web traffic ports to the world. When your app starts to receive more traffic than it can handle, you may wish to distribute the traffic across multiple instances of your web server. It's time to introduce an elastic load balancer. An ELB can be configured to evenly distribute web traffic across each instance. Now, instead of making HTTP requests directly to an EC2 instance, your users make requests to the address of the load balancer, which conveys those requests to the underlying instances. In terms of network security, the EC2 security group should be configured to allow only web traffic from the elastic load balancer. Meanwhile, the ELB itself has a security group which should be configured to expose your web traffic. The app still has a single interface or web address, the ELB now, instead of the single EC2 instance, but it has much more capacity on the back end. Some of the benefits of AWS Elastic Load Balancing include high availability, fault tolerance, and integrated SSL support. In addition, they also provide cross-zone load balancing, basic HTTP health checking, and integration with...
Okay, I was wrong. AWS elastic load balancer features. So it can cross-zone load balancing. Also can perform a basic HTTP health checking. Yeah, and integration with auto-scaling groups. Some of them are the characteristics of a load balancer or
AWS
features.
auto-scaling groups.
Yeah.
You need to open up listeners on your Elastic Load Balancer so that they can receive traffic. ELBs may listen on any port and forward to any other port on the back end. ELBs can also be internal, meaning they only allow private traffic and are not exposed to the web. Finally, ELBs are subject to the security group that's attached to them, so you can apply security the same way you would to an EC2 instance. A secure web application should use HTTP over SSL, or HTTPS as it is often known, to ensure that traffic sent to and from it is encrypted. SSL termination refers to the point at which traffic stops being encrypted.
They say the SSL termination. They are talking about that it is possible to perform. So I was wrong there as well. We can use we can perform an SSL termination as well. Yeah. Also the HTTP healthcare
refers to the point at which traffic stops being encrypted and starts being plain text so that the application server can process it. In a single server scenario like this, you'd install an SSL certificate on the server itself. Of course, your web app needs its request in plain text, so the encrypted SSL traffic is terminated, that is, decrypted, on the server, and your web app can process the request. Elastic load balancers let you install the SSL cert on the ELB itself. Then, you can have your instances listen on unencrypted ports. Traffic is encrypted up into the ELB, terminated by the ELB, and then continues on as plain text. If your instances are private, unencrypted traffic is never exposed. An exciting recent addition to the AWS catalog of services is AWS Certificate Manager. AWS will issue an SSL cert for your domain for free, provided you are using AWS load balancers or CloudFront. Not only are they free, but they are fully managed. AWS handles cert renewals for you automatically. Whether you're using Cert Manager or you've bought your own certificate, the next step is to enable a secure listener, such as HTTPS port 443 on the Elastic Load Balancer, and associate the listener with the cert. Finally, a nice aspect of this method is that if you deploy the same cert to multiple load balancers and you later need to update that certificate, you can do so from one place. Each EOB that uses the cert will be reconfigured. Finally, a word about AWS application load balancers. Application load balancers differ from Elastic Load Balancers, now called Classic Load Balancers, in that they make decisions at a different layer of the networking stack. Whereas ELBs can only blindly convey traffic from an input port to an EC2 port on the back end, ALBs can make layer 7 decisions, meaning that they can look at the URL or HTTP header, parse it, and decide based on that where to send traffic. They can also route to multiple ports on a single machine, giving you even greater flexibility than what is provided by a classic ELB.
Okay, I'm not sure about the answer. I'm still not sure about the answer, but let's try one more time. Okay, what can you not do on Elastic Load Balancer? So, as we have seen, we can perform HTTP health checks, we can terminate SSL, load balance across multiple EC2 instances, and I guess it's this one, direct traffic to an RDS instance. They didn't mention that part, so I guess we cannot do that. We cannot direct traffic to an RDS instance. Okay, cool. So the next question is, which is an advantage of horizontal scaling? Calls scale more slowly, can be automated without scaling groups. You do not have to incur downtime. All of these answers, which is an advantage of horizontal scaling. So this is about horizontal scaling. Calls scale more slowly. It can be automated without scaling groups. You don't have to incur. I guess the answer is all of them. I guess it's all of them. Yeah. Which is an advantage of horizontal scaling. So advantage is calls scale more slowly. Yeah. It can be automated without scaling groups. You do not have to incur downtime. Yeah. All of them are true. By default, security groups deny all incoming, all incoming, all going, no, all incoming traffic. By default, security groups deny all incoming traffic and allow all outgoing traffic. Deny all incoming traffic and allow. So they deny they deny all incoming traffic, and allow all outgoing traffic. I think there is the answer, the right answer. Non-dangerous, non-secure, deny public, deny all outgoing traffic and allow all income. Yeah, I think the right one is this one. Yeah, am I right? By default, security groups deny. So the security groups policies deny all incoming traffic and allow all outgoing traffic. Cool. Let's keep going, my friend. So this is the last question. AWS Linux instance allow password authentication by default. So allow password authentication by default. AWS Linux instances allow password authentication by default. I guess there is false because as we have seen in the previous video, and they was using SSH with a PAM, so you need to perform a command, and you need to perform an SSH command, yeah, and you have to pass the flag minus I, and then specify the PAM file within your computer. So I think the answer here is false, because by default they don't support password authentication. They support private, public and private keys. So that is false. Yeah, AWS Linux instance allows password authentication by default. You're correct. Yeah, this is false. Yeah, they do not allow password authentication by default. You have to use your public key in order to log in into the instance. All right, that was good. We just made two mistakes, I guess. We're doing great. We are doing great. So I'm not sure how much time we have been recording this. Next chapter. I think I'm going to stop the video here.
AWS console. Here we are at the home.
Okay, what is the next? So the next chapter is create an EC2 instance. Oh, that will be cool. That will be pretty cool. That will be pretty cool. But I guess I'm going to stop this video because I don't want it to be very long. So yeah, in the next video we are going to start creating an EC2 instance finally. Okay guys,